I think we have a complete disregard for our environments.
Water's drying up, which is kind of silly because it rains all the time everywhere.
35 to 38% of the greenhouse gases are produced by just 5 materials.
सरकार हमेशा बहुत अच्छी स्कीम्स लाता है, बट वो लोगों तक नहीं पहुंचती है.
There's so much research around solutions, so where is that gap?
We have found more than 25 ways of building earthquake-safe buildings without using cement.
What will people pay for? People will pay for design.
We thought of coming up with a model solution that can be easily replicated.
With analytical tools available, it really makes sense to use data to optimize design.
We're facing a climate emergency, but it's not irreversible if we act swiftly and decisively.
I wanted to build an Uber for waste. Every bit of waste is a resource.
The footprint of this project is hardly 20% of the entire site because the unbuilt is as important as the built.
Very quickly I learned that the person making the big decisions was the person who is controlling the money.
I think adaptive comfort has to come back into picture.
You have to talk to the people. If you want the project to reach somewhere, you have to involve them in the process.
अगर कोई बहन एम्पावर हुई तो वो बेनिफिट पूरे एंटायर फैमिली को मिलेगा.
Tiling industry is massive. Even if you change 10% of it, there's a huge carbon emission saving that we would do.
Now this is suddenly sustainability that is offered not at a premium.
Disruption can bring the world to its knees, but it can also breed innovation. Today, the world over, there's increasing conversation about net zero buildings. However, designing or building one isn't without its challenges. This is also a fairly complex and often misunderstood subject, with varying interpretations and perspectives. That's the theme of our conversation today with Sachin Rastogi, founder of ZED Lab, a Delhi-based research-driven architecture and design studio that specializes in affordable net zero buildings. So Sachin, what I want to start with today is the name of your studio, Zero Energy Design Lab. Now, as an architect starting out, that's quite the statement to make. So at what point in your career did you decide that this is the path you want to tread? And at what point did you decide on this name?
I remember during my thesis time at School of Planning and Architecture, we were asked to look into what building typology you want to take up for thesis. And I started looking into sustainable architecture then. And my thesis was mentored by the greats like Dr. Arvind Krishan and was mentored by Mr. 𝗗𝗂𝗿𝗀𝗀𝗀𝗀 himself.
Oh.
Yeah. So that is where the interest basically started. And then I went for my master's at AA, and that's where I was globally exposed to this whole concept of net zero buildings, and was given lectures by various experts in the field. After completing my master's and gaining a little more exposure, especially while my international work exposure with Building Design Partnership, where I was a sustainability consultant, is then when I saw that India has previously being exposed to good architecture with respect to energy efficient approach from the passive design point of view, but the approach to net zero was not there. And that's where I thought that this is what really excites me, to change the kind of the approach towards how the modern 21st century architecture in India can be. And that's where I thought the name will be very relevant. And I opened the studio back in 2008 along with my wife.
You also have a very distinct architectonic signature, the kind of geometries that you use, the kind of volumes that you create. And to my mind as a viewer, it looks like it enmeshes some parts of Indian culture, and I see some Western references also. So what do you look at or who do you look at as inspirations for your work?
So there are many inspirations. I mean, in India itself, we look at Mr. B.B. Doshi's work. What really, kind of very challenging for me was when I was a student, to do simple buildings, which were very appealing. And that's where I realized that Mr. Charles Corrier's work, Ando, or some of the modern Brazilian approach, I find quite interesting in the way that they were very simple and in expressions as well, very true to what's happening behind. So they were not pseudo elevations. They were volumes. They were very true to the functionality of the building, and that's what I wanted to bring about in my architecture as well. And then we look at what India already had, because that is something which I was always interested in. My maternal grandmother is owning a haveli in a village, and I used to go as a child and live over there, and that used to be a more fascinating place for me as a child than my house in Delhi. So it used to have larger courtyards, where we used to sleep, and the verandas, we used to be on the roofs as well. And we used to play there, sleep there, and do various activities. And I used to wonder why this kind of spaces are kind of extinguishing from, the modern cities. And that's where we thought that, the amalgamation of these spaces with that, expression could be the architectural statement which we can look into.
So I want to go back into the foundational work that you do, which is net zero architecture. And there are obviously steps to creating that sort of work. The first and the most critical is understanding how much energy your buildings consume. So how do you, in your process, start with, once you get a project, for instance, we're sitting in this lovely campus at St. Andrews right now. What was the client brief when this project came to you? And was energy consumption even a part of that brief?
In Indian context, especially in educational institutions, the only brief is that I want these programs to be fit in the building. I want the footprint to be minimal. And the primary objective the architect has to achieve is the cost. So it's a backward approach rather than approach towards the design. So they were not looking for sustainable buildings at all. And they were neither looking for any remarkable architecture. So the initial two buildings built in the campus were built by the contractor. There was not even an architect involved. And so it's more of our internal brief and understanding of what we want to do within that tight budget. And we not only design this building, we actually end up building them because of this budget constraint. Because any contractor we went to with an innovative scheme, which they have not done previously, they don't know how to cost for it or how to incorporate that cost of unseen, And that's where we thought that we need to get into picture if we need to do anything, experimental within this tight budget.
So when you're creating a concept for a building that's again experimental or alternative, how do you even go about measuring its performance or predicting its performance?
So this is where my experience at BDP really helped. So BDP had this philosophy of measure, minimize, and mitigate. So this 3 key M. So you first measure, and then you try to minimize. So while measuring, we do energy modeling of the initial concepts, and we understand what will be the outcome of a certain design approach.
So there are multiple iterations then?
Yes. There are multiple iterations, and based on certain design changes, we try to minimize it. And then we mitigate it through renewable energy.
So why don't you talk a little bit about this project and how you were able to minimize your energy consumption?
So the building basically get heated up for 2 reasons. One is the internal gain, and one is the external gain. The internal gain, there is very limited you can do about it because the building will be occupied by a certain number of users, and they will be using the equipments they may want. Yes, we use energy efficient equipments based on BE guidelines, but as a designer, our maximum effort is in designing these spaces so that they can optimize the energy performance of the building, and we don't have to rely on additional features later on. How we approach is by first understanding, the building volume. And once we have understood what the building volume is all about, we create iterations wherein we understand how the solar movement and different iterations in geometrical interventions can actually minimize the intensity of direct and the diffuse radiation falling on the building facade.
So for instance, I see within this group of buildings here, a very stark element where you have these freestanding screens that shield the building at every level. So
when we studied Indian vernacular architecture, we understood that why they were performing so well was because of this third dimension of space between the inside and the outside, as they helped in cutting off the solar radiations from the principal facade. So these third dimension spaces in form of verandas and courtyards keep the principal spaces cooler all throughout the day. And they allow ventilation as well. And they were very, very pleasant spaces during the evening and the morning time when the outside air temperature is milder. So people used to step out and use these variety of spaces. And we thought that there's very little which the client allows you to do with the space, So we let the building be, and we built an envelope around it, creating this third dimension space for the building, protecting it from the direct and the diffuse radiations, from the convection and the conduction heat gains from the air temperature, and also provide an opportunity to the user to experience a third dimension space, which is beyond the building program.
I think another very critical aspect of looking at energy consumption and minimization is looking at it through the lens of efficiency and looking at it through the lens of hard data. Were you able to study the effect of or the impact of these interventions on actual heat gain and what came out of that?
Yeah. So in most of the project we do these iterations and we monitor them very, very specifically. So let's say in case of the boys' hostel facade, we first analyze how much solar radiations were falling on the principal facade. And while making the second skin, we altered the skin in multiple iterations to optimize how much solar radiations can be reduced so that the daylighting is not compromised, and yet the building facade would receive minimum of direct radiations and maximum of diffuse radiation. And that really helped us in reducing the building temperature indoor. While the outdoor remained 45, the indoor never exceed 32 degrees. So there is that significant drop just by adding that layer. That layer is typically added by, skins which are very lightweight, like aluminum louvers, like metal jalis. We didn't want it to do that. We wanted to have it real impact. So the second skin here has a lot of thermal mass. So we have either done it with real bricks, which absorbs the radiation and release it during the night time. Here again, the vernacular really helped. So when we look into our havelis, we'll look into our palaces. They've used a lot of jalis, especially Islamic architecture. And they were also built with concrete or stone, which has very effective thermal mass. And whenever we visit these spaces, they remain cooler, irrespective of what the temperature outside was. And that always, create a lot of interest as an architect in me, that without technology, this can be achieved. In House Under Shadow, the primary source of heat gain because of a single-story structure was roof, unlike at St. Andrews, where it is the facade. And we know that in Indian context, they use the roof a lot. So we didn't want it to just use insulation. So we were not just looking at the building, we were looking at adding a kind of a umbrella over the building in a format that it shades not even the building, but creates a beautiful environment on the roof because it is extensively used for social activities. And the courtyards, the swimming pool, the verandas, they also become extremely more comfortable by adding this third layer. So we created this parametric roof, which basically creates that impact.
So you spoke about parametricism and how you're using that to your advantage. The biggest challenge is how do you work with digital software and modern technology with the kind of skill and labor we have on site in India? So how do you deal with that challenge?
Yeah. That's quite a learning curve for us. So we see Zahadid's work, and we see many others, taking parametrics as a form developing exercise. And here we thought that, and you can't really sell a form-driven exercise to the client, especially in a tight budget project. So how can we use, technology to actually create more value in the building? So we wanted to create these envelopes using parametric modeling. Why parametric modeling? So if I have to create an optimal facade which can minimize solar radiation, and if I do it manually, I would really take
to do it.
Yeah. And it's such a tedious task that I might look for an easy alternate. And I will never be able to build a brick facade, which is 240 feet long, 25 feet high, probably one of the biggest brick jallis built without using any cement mortar. So, so we looked into that aspect as taking the data in, and then very easily you can do multiple iterations using the same data to create different expressions, which suits you well. So like in this case, we wanted the bricks to rotate in a particular way to kind of shade and yet work as a very effective thermal mass. So when we got these varied angles of the brick, we were wondering, because the overlap was so less that you can't really use mortar to erect this. So the challenge was that how to do it. So we went to the contractor, and they also guided us, and then we went to the manufacturing unit as well. And what we came to the conclusion with was that we'll manufacture the brick with a single hole, and we got a steel rod inserted through them, and that's how we were able to bind them and erect this facade. So
and you did this yourself?
Yes, because whenever we went to any contractor, independent of us, they were charging us a huge amount, and because this is an unknown to them. So we worked with our own internal team of contractors, and we tried to optimize the cost. We made changes in the design, and instead of using any technique, typically in Europe, you would erect this kind of a structure using robotic arm. We can't really afford that here. So we use scaffolding, we use hand-on tool. So we created a geometrical object which can give us various angles on the site. And that was basically developed by the contractor himself. And one of the person from my team would stand there, take the readings from the software, tell them the angles, they will rotate each and every brick. And once one line was achieved, then it was a very, very easy process to replicate. So that's how we were able to build these very complicated facade using the local techniques and the skills. They were also upgraded.
So what has your learning been through this process of getting your hands dirty?
So earlier what we used to do is that we used to sit in the studio, do the working drawing, send it across, and there was no communication, and the project manager will look into the whole process. Here, when we, actually went to the site and started interacting with the contractors, we realized, that we never thought about that the construction can be tweaked, or the working drawing can be tweaked to optimize the cost of the building, to optimize safety features for the contractors on site, and also, how we can eliminate technology and use the local skill set to build anything complex on site. Sitting in the office, it's very easy to say that, this is how we are going to utilize modern tools or technology, and why are we not able to build certain complex facade. But you need to understand how their own system works, and you need to modulate your input based on how they will be able to take that input and create something interesting on site with you. So these were very, very good takeaways, and we have realized that visiting the site and being part of the construction process for an architect studio is very, very important.
I'd now like to go to the second part, or the second step of creating net zero architecture, which is you've measured the performance of your building. You know how much energy this building is going to consume. How do you balance it out by creating new energy on site? And that's a very, very challenging task. Yeah. And a lot of architects today are struggling with this part of the equation. How has your experience been with the projects that you worked on creating energy on site, and what are the challenges you faced?
So integrating renewable energy in the building is easier said than done. So there are two challenges. First is the initial cost. Now, you do have, however, participatory models where the companies are willing to lease out your roof rights and erect it for you, where you don't invest anything.
When you say companies, what kind of companies do you mean?
The solar cell, the photovoltaic cells company.
Okay.
They come and they are erecting these onto your rooftops, and then whatever energy they generate, either they feed into the grid and make money out of it, or they give it to you, and then they bill you on that. However, for any photovoltaic to generate electricity and backup to the grid or into the building, they need alternate energy. So they need regular energy supply in form of from the grid or from the generators or alternate energy producers. And that's where, off-sites like campuses which are away from the city, where the electrical supplies are not regular, there they face the challenge, because if you supply the backup energy on generator, then the whole idea of being, sustainable. Yeah.
So you've also designed some really nice residences. So do you find that this is slightly easier for you to apply in residential settings?
100%, because the economic viability is less of a challenge in a residential sector, because client is building a house for himself. He's the decision maker of the house. In an institutional project, there are many stakeholders, so everyone has to be convinced. Here, it is much more easier. They want to, take this approach where they can save tremendous amount of money, So
in the
they,
long term.
yes, so they directly understand the implications of what they are trying to do, and the energy requirements of the building, because it has been mitigated through the other two steps, has already been taken care of. So a typical house, if is requiring say 100 units, a house designed by us would typically use 30-35% less. And so we have a couple of projects where client have been able to do it. And one of the clients in Hisar has showed us the bill. Their monthly bill on a plot of 500 square yard at the end of year is not more than $1,000. So which is he's quite happy.
Another thing that often gets missed when we're talking about net zero is that net zero comes in many shapes and forms. So there's net zero energy, there's net zero waste, there's net zero water, there's net zero carbon. And carbon emissions today are really, really critical to how we are going to imagine the world of our future.
Well, carbon is the main idea worldwide, because the global warming is primarily because of the carbon emissions. So it is a very, very important concern. But the construction industry, even the building rating systems for that matters, are more focusing about the energy efficiency. Even the supply chains are not really ready for that. The vernacular was more sustainable, and the approach was pretty much closer to carbon neutral, because we didn't have concrete at that time. But we are not able to find a good replacement to concrete. However, what we are trying to do here is that by building in load-bearing brick walls, by intelligently integrating, innovative structural systems, we are able to reduce the steel requirements of these buildings, because steel is a major culprit in concrete towards the carbon emission, and that's a little we are, able to do with respect to concrete. With respect to everything else, yes, we have a very, very sharp approach towards carbon neutrality in terms of the brick we have used is locally sourced, locally made. We don't use raw wood in our projects. We use aluminum frames which can be recycled and reuse as well. With respect to any cladding materials, we try to stick to MDF or SDM. So yes, to these secondary skin, we are able to do it there, but in the primary structure of the building, the approach is still not carbon neutral.
So when you're working with alternative material sourcing, or you're trying to pitch to a particular client that you should try this new material set that they probably do not think is modern, they do not think probably is aspirational, how do you change that thinking?
Yeah, that's a very, very valid question. So with respect to the budget, it's a very, very simple approach. So we don't use global materials which are imported. We try to use locally made materials. So they're not only sustainable, they're cheaper. And then we don't use any extensive technology to apply them in the building. We are using the local laborers or contractors to apply them to the building. Again, hence the application as well as the production cost is pretty low.
So then that's your argument to the client?
Yes.
Of reducing the cost?
Yes, but the counter argument always is that, it's not really what I want. So, and that's where the technology in design, while using parametric software, we are able to reuse or reinterpret these materials in a very different format. And that is how the clients get convinced that yes, even a global aesthetic or a 21st century architecture building can be relevant using local materials.
India and the global south are going to be urbanizing quicker than ever before. And we will be adding billions of square footage of building stock to our cities in the near future. In the context of the challenges that you've mentioned, what do you see as the potential for net zero architecture today?
Net zero is very challenging because the amount of energy we are consuming as humans is pretty high. And yes, the technology is improving, but the approach to comfort has literally changed. Adaptive thermal comfort idea is going out of the window, and we are moving towards making everything, even the outdoors, we now want to make comfortable for ourselves. So we are utilizing, shading devices, we are utilizing more conditioning fans so that we can sit outdoors all throughout the day. That's not the way, you can approach net zero in a more affordable way and in a more promising way. I think adaptive comfort idea has to come back into picture. We need to understand where we are, who we are. The global approach cannot be same for every context.
And what do you think the industry can do? Architects, designers, product manufacturers, and what do you think the government can do? Like, what are the top 2 or 3 things that you feel can be done in order to make this more mainstream?
As a design fraternity, we need to understand the vernacular and place specific architecture. That's the role of the architect, and educate the client. So the client will, because of their limited exposure, whatever they have seen globally, they will come back and ask and demand for it. But as an architect, it is our moral responsibility to educate the client of what is he needing, what is the context he is building in, and what should be the right approach for that place. With respect to the industry also needs to understand that importing global products which are not really suited for Indian or any other country context is not really the way forward. So the industry has to develop products which are more suited for the local climatology with the local material palette. With respect to government, people will not take these initiatives until or unless government starts giving initial initiatives to at least kickstart these approaches, or give some incentives to people to at least look into these directions. So that can be the role of the government.
So thank you so much, Sachin, for sitting down with us today and helping us deconstruct the idea of net zero architecture. I think it's really important for us to understand that on this journey towards net zero architecture, we will need an incremental approach. We will need concerted efforts from multiple stakeholders: architects, designers, manufacturers, governments, and even a broader change in the industry and popular perceptions if we are to build a more responsible future for us all.